Hello, my name is Simon Bennett. I'm the ZAP project lead, and my work on ZAP is sponsored by Crash Override. And today I'm here to talk about ZAP Authentication, what it is, why it is, and how you do it. So to start with, I'll just say what is ZAP, because hopefully most of you know what ZAP is, but for those who don't, I'll give a very quick introduction. So ZAP is a tool for finding vulnerabilities in web applications. And it is not a kind of vulnerability scanner that looks for known vulnerabilities. It doesn't search for CVEs. It doesn't typically look for known problems with known plugins to WordPress or anything like that. So what ZAP is, it's a tool for finding new and interesting vulnerabilities in custom web applications. ZAP is completely free and open source, and is very actively maintained. That's something I always like to stress because I try and keep a track of all of the open source web scanners out there. There have been a lot have come and gone in the years. I released ZAP in 2010, and we've seen a lot in that time, and very few stick around. Maintaining a web scanner like ZAP is a lot of work, and people find other things to do or lose interest or whatever. So ZAP is one of the few tools that of its type that has been very actively maintained for 14 years now, something like that. There are lots of different ways you can run ZAP. So there's a desktop app, which is typically used for when you're testing an application manually. We have a heads-up display, and that actually brings ZAP functionality into the browser, so you can focus on your application and still see ZAP information brought into the browser and control ZAP that way. We also have a daemon mode, so you can run ZAP headless and control it by the API. The API is very powerful. It's nearly as powerful as a desktop, so you can do pretty much everything you need to do in automation that way. We also have GitHub Actions, which allow you to do baseline scans, API scans, and full scans of applications. And we have a lot of command line options, including the automation framework, which is particularly powerful and ideally suited for automation. And finally, ZAP is, we believe, the world's most popular web scanner. It's kind of difficult to tell because commercial tools typically don't release information on how many people use them. But I've been saying this at conferences for many years and no one's disagreed with me, so it must be true. And we also publish statistics about ZAP. So go to zaproxy.org/statistics, and you can see how many people we know used ZAP last month, for example. So, subject of this talk, getting ZAP to handle authentication. Now, what do we actually mean by that? So, it means several things. First of all, authenticating to your application. So, providing valid credentials and getting some sort of token back. Now, this could be via login form or API calls, whatever's necessary, but it's just providing those credentials, valid credentials, and being authorized to access the application. Next up is session handling. And this is very important because HTTP and HTTPS are stateless. So there's no built-in state, which means applications have to maintain sessions in other ways, non-standard ways. Now, often these are just things like headers, but there can be a whole range of options that applications can and do use. And so it's not always as simple as you might like to actually handle a session. And then there's verification. And this is something that a lot of tools that claim to handle authentication don't actually do. So some tools will allow you to specify session tokens, but they don't check whether they're working or not. And that's one thing that ZAP does. It actually allows you to check that session tokens are valid either on every request or polling. This is very important because, as I'll explain, session tokens can become invalid. And finally, confidence. So one of the things that is really important, I think, is making sure that you know that things keep on working. And this was brought home to me a few years ago when I worked at Mozilla. So I was responsible for automated scanning of Mozilla applications, websites, and I set a scan up for one particular big application, got authenticated, got it all working, everything was fine, And then a few months later, or it might have been a year or two later, it stopped working. And I knew it stopped working because I got an alert because I put specific checks in place. And the reason it stopped working is the team had actually changed how the application authenticated. So everything was working fine until they changed stuff underneath my feet, pulled the carpet out, and it stopped working. So I put specific checks in for this, and we've now got a way of doing this much more easily in ZAP. If you don't have that, then how do you know it's carrying on working and it could break and you never find out about it? So what benefits do you get by getting ZAP to handle the authentication? So the kind of obvious thing is most real functionality that applications provide is protected by authentication. You don't want unauthenticated users coming in and making random changes to the application. So usually, some applications have unauthenticated content, stuff you can read. You might be able to do searching and things, but to actually do stuff, you typically have to be authenticated. And if ZAP can't authenticate as part of its automated scanning, then you won't be testing all of the interesting things, all the things where there might be cross-site scripting, SQL injection. Those sort of things are usually found in parts of the application which allow you to do things, submit data, change things, and that is usually provided protected by authentication. So if ZAP isn't doing an authenticated scan of your application, it's probably not doing much of use. Now, I mentioned that you can just supply your own session tokens, but we do know that session tokens time out, for example. I've often seen session tokens which last 15, 20 minutes. And the problem is a full ZAP scan or a scan from any DAS tool can take a significant amount of time. It can take hours sometimes. So if you've got a token that times out after 10 minutes and you're not refreshing it, then the first 10 minutes will be doing something useful. And after that, you're going back to an unauthenticated scan. So session tokens timing out is a significant problem. The other problem is logout functionality. So one of the key things to making a scan successful is exploring your application effectively. If ZAP or any other tool can't explore your application very well, it doesn't know what there is to test. There are various ways you can explore. You can proxy unit tests through ZAP, or you can use one of the two spiders. So we have a traditional spider, which is fast and furious, but works much better with traditional web apps. It doesn't work so well with modern web apps that use a lot of JavaScript because you can't typically find URL links in the application, in the HTML. So for modern web apps, we have what we call an AJAX spider. That launches browsers, clicks on things, fills in forms, handles web apps much better. It's slower because it's being controlled by a web app. But either of these can hit logout functionality accidentally, unless you specifically prevent it from doing so. And you might make a mistake, so it's quite easy for the logout functionality to be hit, maybe via unit tests. We might import API endpoints that include the logout feature. So this is another significant problem. And finally, we do know that session tokens can be invalidated, often because it appears the app is doing something bad. And that's what ZAP is here for. ZAP does bad things. So it's not uncommon to see session tokens invalidated because ZAP has hit some sort of checks to see what's being done. And that is something I'd like to stress is if you have these kind of security features, it's always best to turn them off in a safe environment where you're testing your app with ZAP because really you want to test the app and not the security features. Finally, ZAP can tell you if things go wrong. As I said, I found out the hard way that things can change under your feet and something that's working for months or years can break. So ZAP has features which allow you to see that these things are going wrong and will tell you so you don't have to go in and keep on checking the results every time. So how can we get ZAP to handle authentication? And unfortunately, the answer is it's complicated. Authentication is hard, and there are loads and loads of different ways that applications handle authentication and session handling. So there is no simple button, and I've not seen any tool that provides any simple options here. It's all complicated. good news is there are some easy options. So first of all, if your app doesn't have authentication, or you've got an option to disable authentication, then do it. Make your life easier. Disable single sign-on, keep it as simple as possible. And if you don't need to use authentication, if you don't need to configure ZAP to handle authentication, don't bother. It's not needed. Don't go down that route. Don't make things complicated for yourself. The other case we find is sometimes you have session tokens that are easy to generate and don't get invalidated. Unbreakable session tokens, I've called them. These are great. If you've got these available, then definitely use them. Unfortunately, we see that, this isn't usually the case, but if you've got that option, go for it. And there's different ways you can supply them. So we support authentication environmental variables. These are great because, very little configuration, but they only support one header, one value, which you can constrain to particular sites. So very simple, but it's limited. We also have a replacer within ZAP. So there's a tool which allows you to replace anything with anything else. And these replacer rules are really powerful. So an ideal way of specifying session tokens. And we also have scripts. Now, ZAP scripts are insanely powerful. You can get scripts to change pretty much anything to do with ZAP. You can change requests on the fly. Those really powerful, essentially reprogramming ZAP on the fly. So scripts will allow you to do pretty much anything. So these three options are very good ways of handling authentication yourself when you know it's going to work and it's not going to break. So these options we find work well for APIs usually, but they don't typically work for modern web apps with modern web UIs. Why is this? Well, it's really because of the way applications work these days. There's so much functionality in the browser. And what happens is you end up with session state in the browser. And it's really hard to inject session state into a browser. So if we want to explore an application using the Ajax Spider, the Ajax Spider will launch browsers, and to actually inject state into that is non-trivial. It is possible. I've got a blog post explaining how you can do that with OWASP Juice Shop, and I've seen other real-world applications where it is possible, but it's always very application-specific. And I have seen applications where it just doesn't seem to be possible. So it's very, very application-specific, and it can be very painful to work out. So if you've got session tokens, they probably work well with APIs, but modern web apps, you'll probably find they don't work. So what can ZAP support? Well, we can support pretty much anything that can be supported in authentication. We have very low-level support, and I've heard of people doing insane things with ZAP to get it to cope with pretty much anything. There are some exceptions. Obviously, you've got a two-factor authentication and you can't get the token to the box ZAP is running on. What can ZAP do? If you can't get these tokens to ZAP, there's a problem. And that's not a problem with ZAP. If you can get MFA tokens to ZAP, you'll be able to configure it to handle them. But the problem with the ZAP low-level support is you need to configure it. So you need to tell ZAP exactly how to authenticate, exactly how to maintain the session, and how to verify the session is still valid. And what we find is that most people don't actually understand how these things work in their applications. And it's actually a good thing, because what it typically means is development teams aren't rolling their own authentication or session handling. They're using third-party products, third-party services. The security teams often don't get directly involved in these things, just make sure that the developers are doing the right kind of things. So even the technical people in a company might not know how everything works in detail when it comes to authentication and session handling. You'll be able to work it out, but it can be tricky, and debugging can be painful, particularly debugging if you're running in CI/CD. That can be very, very painful. It's hard enough debugging in the ZAP desktop, but as soon as you lose the desktop, it gets really tricky. So ZAP has very powerful support, but we found that people can struggle with it. So are there any easier alternatives? Well, yes, there is. We have what we've called authentication auto-detection. And this is really powerful, and we found it actually handles a significant portion of web applications, particularly modern web applications. So what this does is it actually uses browser-based authentication. So it launches a browser, and you need to tell it where the login page is and what the credentials are, and ZAP fills those in for you. It then will try and detect what the session handling is and what a good URL to use for verification. You can do all of these things yourself. You don't need ZAP to do it, but ZAP will do it pretty well in many cases, and it's more likely to get it right. If it fails at any stage, don't worry, you can still carry on doing things and working things out manually, but it might give you a really good step up. And in some cases, we know that there are some strange login forms that ZAP can't handle yet. If you find one of those, then please let us know. We want to know details so that ZAP can handle things better. But we have options like the Selenium scripts, which mean that you can actually do the logging in via a browser as well, and it will then carry on working in the same way. So if ZAP authenticates via a browser, then it can do that in the browsers that are launched by the Ajax Spider. That means we get the session state into the browser, and the Ajax Spider can explore the application authenticating. So this is a really good solution. And what we have is we've got an option to actually test this in the ZAP desktop, and you can then export the configuration to work in CI/CD. And this is fully supported by the automation framework. Now, so the automation framework is a way to actually control ZAP, and you control it via a YAML file. So this it supports all of the key things that you'd expect you'd want to do when controlling ZAP in automation, and it allows you to put it's very flexible, and it's much more flexible than some of the, say, we've got some GitHub actions and package scans, which are included in our Docker images. Those are good, but they are somewhat limited, whereas the automation framework is much more flexible and much better support. It's got full support for all the authentication options. And the good thing is that auto detection works very well with this as well. So what I'll do now is, I think I've got a bit of time, so I'm going to switch over to ZAP, and this is the ZAP desktop. And what I'll do is I will go to find the mouse, which it seems to... Okay, the mouse is not visible. So that's better. I can now see it. So I will go to Tools, and we've got Authentication Tester. So it actually remembers the last login you've tried, and this is what I'm going to use is JuiceShop. So I've got the details there, the login page, test@test.com, and test123 is the password. Just check I've got that right. And what I'm going to do is this uses, I've got it down as Firefox, and we're not going to use headless because we actually want to see what's going on. Now, by default, JuiceShop doesn't come with any users, so I've actually manually configured test@test.com. So this has been registered and should work. One thing you'll notice is we've got a time to wait, which I've set to 5 seconds. That's the default. This is necessary because I've found that some modern web applications can take a while to load. And what we need the web application to load, and then we need it to make some requests so we can actually see what's going on and what session handling it's using, and see if we can identify a good verification URL. Now, if ZAP fails to find the session or verification URL, you can actually increase this time. If ZAP successfully logs in, you can play around with the browser. Once it's logged in, you can click on things, and hopefully ZAP will then detect the session and verification URLs. But with modern web apps, that's typically not necessary. They usually make loads of requests in the background. But if ZAP closes the browser before the application's loaded in the browser, we're not going to get anywhere. So time to wait of 5 seconds. I've seen some applications take 20 seconds to log in, or not to log in, but to actually initialize. That's awful. Really bad user experience, and not good for automation tools. ZAP can handle it, but you need to make sure that you actually increase the time to a suitable amount. There's also a demo mode here. All this does is actually add a couple of second waits before doing things, just so I can talk over things like I'm doing now. So that's really for me. So I'm going to click test, and we should hopefully see Firefox being launched. And I'm actually going to manually dismiss that dialog, but you'll see it doesn't really matter. ZAP would still carry on, and you'll see ZAP filled in the username, the password, and then logged in. So come out, and we'll see that ZAP has identified the username field, identifies the password, identified the session handling, and identified the verification URL. Now what we have is we actually have a context name here. So I can go and see ZAP has actually created this context. And if I make this a bit better, we will see that ZAP has configured browser-based authentication. It has identified a URL for polling. It has put the user in and identified session management. It's actually put the authorization and cookie headers in twice. Little bug there, but it doesn't matter. It'll still work fine. So what we can see is actually pulling out the cookie token from the request. So actually, this is from the cookie. We can get those. There's a whole range of things. So we can actually get things from JSON authentication responses, environmental variables, script headers. We can extract tokens from loads of different places. So what that means is ZAP can actually handle juice shop authentication without any more configuration at all. And we know that ZAP can handle a lot of modern web applications automatically, which is great. But if you do find any applications where the ZAP authentication auto detection doesn't work, then please get in touch, because we want to know more. We want to make sure ZAP can handle things even better. So what happens if something breaks? As I said, I had that case before in Mozilla when the authentication changed under my feet. So what we have is ZAP internal statistics. I mentioned statistics before when I was talking about the number of times ZAP is run every month and things like that. So we publish those on the website. We also have internal statistics, and these are published on the website as well. The names of them are, so you can find out what is available. They're available to you via the API, but they're also available via the automation framework. And the automation framework has some very nice features, because you create jobs for things like the two spiders, the active scan, and with each job you can include a set of job tests, as many as you want. And there are different types of tests, one of which is a statistics test. So you can take any of the ZAP statistics and you can check that they are greater than certain values, less than certain values, exactly the same as something. So you've got very fine grain. You can put as many of these in as you want. We actually, when you create an automation framework plan, the spiders, we put default ones in. So, you check that you find at least 100 URLs. We've no idea how many URLs you expect to find, but we put the test in there as info level. You can then change it and say, right, if we find less than 200 URLs, something's gone wrong, we should fail. But we can do exactly the same way with the authentication statistics. ZAP has loads of statistics, including everything possible around authentication, so you can check things at a very fine level. And that is the URL for the list of the internal statistics available to you via ZAP. If you want more help, then go to zaproxy.org. There's loads of stuff on there, loads of documentation, a lot of stuff about the community, and various support options as well. And that is it. Thank you very much for listening to me. My name's Simon Bennett. I was talking about ZAP authentication, and please get in touch with me via email address there, or PSIINON is my Twitter handle. I should be easy to find, so please have a play around with ZAP and let me know how you get on. Thank you very much.